Okay, very good. So let's switch to English. Thank you very much, Michael, for the warm welcome. Love to be here, at least virtually in Cologne. I had the honor to visit Cologne and .NET Cologne and the .NET User Group Cologne multiple times in the last years, and today it will be remote. So I'm really happy to join you again in this nice community. My topic today is managed identities. I personally think that managed identities is a super important topic when it comes to Azure, because it's closely related to security, and security is super important when it comes to the cloud. Because if you build a software as a service solution running, for instance, in Azure, then the trust of your customers is super important and a determining factor when it comes to business success. If your customers don't trust you because you're losing their precious data, then you probably will lose a lot of business. So keeping applications secure in Azure is vitally important for software as a service vendors. And managed identities, they solve a core problem that we have had for many years, not just in the Azure cloud, but in general, and that is, how do we keep secrets secure? With secrets, I mean things like API keys, I mean things like database connection strings, I mean keys to, I don't know, a container registry, to a database, whatever. Though keeping those keys secure is really hard. You have these keys maybe locally in a config file, and it might just happen that you check in this config file and suddenly all your keys are in a Git repository. In Azure DevOps, in GitHub, if things get really bad, then your API keys or connection strings are suddenly in a public GitHub repository and everybody can see it. But even if you only check it in locally in a GitLab or Azure DevOps environment that is protected, everybody in your company who has access to the source code can suddenly see the API keys. And maybe you don't want that, because these API keys refer to a production environment where only a limited number of people should have access, because you store, for instance, customer data there. So where could you secretly store all these keys? You could say, well, use some kind of password manager or key vault or something like this. Okay, then I would ask you, where do you store the access keys to the password manager or to the key vault? You have the same problem over and over again. There is no simple solution for that. Even if you say, hey, we don't use keys, we use client certificates, for instance, then my question is, where do you store your client certificates? It's somewhat not that easy to get rid of all these secrets, and that is what managed identities is all about. And I would like to cover in the next approximately 60 minutes managed identities, but not just scratching the surface. What we are going to do is we are going to see a code-only talk, so you will not see any slides. We will deploy a non-trivial solution consisting of a little bit of ASP.NET Core, a little bit of Azure Functions, SQL, Key Vault, Azure Storage, containers, container registry, Azure Active Directory. We will bring everything together so I can give you a nice overview about what these managed identities are capable of doing. Even if you know a little bit of managed identities, we are going to dive pretty deep today, so I'm looking forward to the next 60 minutes. A word of warning at the beginning: I will do a rather big sample here in Azure, and we will deploy everything from scratch, live, in this talk. So it might happen that something goes wrong. If something goes wrong, please bear with me. Maybe we'll have to do some debugging. We will see, but let's simply try it. It's a lot more fun if we do it code only and do everything live, right? So no pre-baked, pre-deployed magic, everything from scratch. Okay, let's get started. My environment is obviously implemented with infrastructure as code. That's a very important thing, and probably most of you know that this is super important when you develop in the cloud. You have this nice little portal. Let me make my video a little bit smaller, because now it's okay if you see me in a tiny corner down here, maybe this one. It's okay to use the Azure portal to create some resources by clicking on this create button, as long as you do this just for learning purposes and exploring and things like that. But when it comes to productional software development, please ignore the create button here. This is an important one. Whatever you do for production development, always write scripts, just like you change the structure of a database. You wouldn't do that in a graphical tool. You would probably write an alter or create table or drop table script. Same is true here for Azure. You do not create your infrastructure components, your managed identity related work directly in the Azure portal. Please write scripts for it, because only if you write scripts you can repeat the things that you do, you can share the things that you do, you can transfer the things that you do from development environment to test environment to production environment, and many additional advantages come with infrastructure as code. And because of that, everything will be code today. We will just use the Azure portal to take a read-only look at what we created, maybe do some debugging and things like that, but we will not change anything here directly in the Azure portal. So if you are rather new to Azure and you have never really worked with infrastructure as code, make this a big takeaway from my talk. Infrastructure as code is crucial. I don't care if you use PowerShell or Bash or Bicep or ARM template or Terraform. I really don't care. As long as you write scripts. Infrastructure as code, super important takeaway. Because of that, we will immediately go back to my Visual Studio Code here, and I will show you how I structured my talk today. By the way, of course, you will get the complete sources. Everything is on GitHub. It's for free. You can take it. It's MIT licensed. So whenever you find something that is useful for you, take it. But again, a word of warning, this is demo code. This is not production-ready code which has been hardened and added with a lot of error handling and things like that. This is demo code. Still, maybe you find some golden nuggets in there that you would like to copy. Feel free to do so. So let's get started. The only thing that I ran at the beginning is this one here. This is a Bicep deployment. If you've never seen Bicep, this is Bicep. Welcome to Bicep. I will zoom in a little bit, and so you see this is how you define your resources in Bicep. You just say resource and you say what you want to create, and then you define the properties as you can see it here. So just as if you would click around in the portal, here you note what you want to do in a text file, same as what you would click on in the portal, and then you simply run it. And this is the first Bicep file. I will not go into the detail. This is not a Bicep talk. If you don't know Bicep, I'm sure you will get the basic principles. Take a look at it. It's super useful. You could do the same talk with Terraform too. It's really up to you. So this is what I already created. We have here a resource group which I called AZ, like Azure, Managed MGED ID, Azure Managed ID. This is our resource group, and I created that one before because, yeah, it's trivial. The next one is a larger deployment. This larger deployment starts here, and this is this infrastructure Bicep. And if I scroll down a little bit, you will see there is a lot of stuff going on here, and I will walk you through in a second. But while I walk you through this infrastructure Bicep file and especially point out the managed identity portions of it, because this is what we would like to focus on, I would like to run the deployment in the background. So I will mark parts of this part here, exactly, and run this script so it deploys everything from scratch. Ideally, in 5 minutes or so, we have a bunch of Azure resources here. If the demo gods are smiling. Let's see. So let's run this guy here. Just 2 or 3 words about my environment here. I'm using an Ubuntu Windows subsystem for Linux environment here. So whatever I run it on Linux. I use the Azure CLI for doing the automation stuff. And as I mentioned, Bicep for our infrastructure deployment. This is my environment. Some people are always interested and ask me, how do I do that? Well, my development environment is obviously, as you can see it here, Visual Studio Code, which is, as you can see down here, connected with my Windows subsystem for Linux machine. So I'm using Windows for the front-end portion, and everything else is running completely in Linux. So you see here in the background, the deployment is running, and we can check whether this works. I refresh it. We should see here our deployment coming up in a second. Let me check that, and then we will focus on the Bicep stuff. It's deploying, and here we are. Let's run that in the background. This will now spin up a bunch of infrastructure, and I will show you what that is by looking into our infrastructure Bicep stuff. So, get rid of that one, and let's go through it. Here we have a bunch of parameters, like parameters in a stored procedure. If you don't know Bicep yet, it's just a bunch of parameters, like parameters of a method or parameters of a PowerShell script or whatever. Then a bunch of variables. You see some names that I just selected. That's Bicep stuff. Some magic GUIDs which come from the documentation of Azure. Again, this is not our core topic, but then we are in the middle of our core topic, because the next thing that I create is a storage account. Those of you who work regularly with Azure know that in Azure, a storage account is used for blobs, images, for instance, documents, encrypted stuff, just binary objects. You can also store data in tables there, a key value pair table, something like this. There is a queue section there, there are files there. In my demo, we are going to use the blob part of a storage account. So this storage account, as you can see here, does not have unauthorized access, so it doesn't allow public access, and it has, and that is the important thing, no shared key. Keep that in mind. This is the first important thing regarding managed identity. I prevent access with anything else than Azure Active Directory. No shared key. There isn't a key that I can lose. I simply disable the key here. That is a super important setting. So what I have to do, whatever I do, I have to go through Azure Active Directory. Okay? Keep that in mind. Nobody can access our data storage except somebody has an Azure Active Directory account. That can be a user, like me, I'm a developer, or there can be an application. And this is where managed identity comes in. I will show you later on. So remember this setting. Then I have a little bit of permissions going on here. What I do for development purposes, I assign myself, I am the admin here, the storage blob data contributor permissions. So this is just for development purposes in a production environment. I would not deploy this role assignment. This is just so that I, as a user, can manually debug things. In production, this shouldn't be there. Nobody, no user should by default be able to access the storage. This is just something that works through some APIs. Now here we have a second storage account, and this is not relevant for our demo, so I can close it. It's just containing configuration data for our Azure function, for the serverless function. So it's not customer related. We don't need to protect it as strongly. It is allowed to have a key authorization. So we don't talk about that today. That's not our core topic today. Now, if we have storage and we would like to access this storage in some way, and we don't want to do it with keys, how else can we do it? Well, let's take a look at an app service plan first. This will be ASP.NET Core running in an Azure App Service Plan. It is a Linux App Service Plan, and for demo purposes, I'm going to use a container environment. So I have put my ASP.NET Core app, you will see that in a few minutes. We put them in a container and use the container as a basis for our web app. Now, the important setting regarding managed identity is this one. Oops. So again, this one. Identity type system assigned for our web app. What does that mean? That means that the app service web app, the environment in Azure, gets its own identity. It gets a so-called service principal, not a user principal, but a service principal. Why is that interesting? Well, as soon as our web app has its own system assigned identity, then the fact that our code runs inside of this web app is enough to prove that it has access to storage, for instance. So we are getting rid of the secret by replacing the secret with the fact that my app runs in our Azure environment. if the code is there, it's allowed to access storage. And the magic between is covered by Azure. There is no key. There is no key at all. It's just the fact that our code runs in this app service. And this is enabled by this setting, identity type system assigned. That gives us this beautiful functionality. Now, by creating this system assigned managed identity, as I told you, Azure will create the so-called service principal in AAD. In Azure Active Directory, there will be a dedicated service principal, and of course we can take a look at this service principal if we want. It's just like a user principal, but it doesn't represent a user, a human being, but it represents a service. And the maintenance of this service principal is done automatically. For the Azure experts in the virtual room, this means creating a service principal means that an enterprise app is created in the background. So you can take a look in Azure Active Directory under Enterprise Apps and you will find your web app because the identity system assigned was selected here. Okay, this is with this flag here. So a bunch of settings, not that interesting. And then we have another here, a web app. Oh, sorry, I screwed something up. This is the Azure function. I will show you both an Azure function and I will show you a web app. So sorry, this is the Azure function, and down here we have the web app, okay? And again, we are going to use system assigned identities, so we will have two service principals, one for Azure Functions and one for Azure Websites. Let's see how our deployment goes, and I see, woohoo, it's done. You see, a lot of resources were deployed and we have a lot of green checks. That is exactly what I want to know and I want to see. So let me show you now in the Azure portal what the result of the settings are that I just showed you. So let's take a look at the web app here, and if I go to identity, then you are going to see that this thing has a system assigned managed identity, and here you see the object ID of the service principal, the object principal ID. This is the web app, and this time I'm correct. This is the web app, and if I go back, this is my Azure function. It's the same here. I can click on identity, and again you see a system assigned managed identity with the service principal. System assigned managed identities are great because they are automatically deleted if you delete the web app or the function. So you do not need to manually maintain them and create them and pet them and feed them and keep them alive. They are fully managed by Microsoft and they are deleted if the related resource, in our case a web app or a function, is deleted. Super, super useful. The question is, why does this web app and the function now suddenly have access to our Azure storage? The answer is they don't. We explicitly have to define the access permissions. And you see, let's take this one as an example. I just put it here. Here I say, please take my web app. To be more specific, take the service principal of the web app and assign it storage blob data contributor permissions to the data storage. So now I can take the service principal, which represents the code running in Azure, and I can say every code that runs in this environment should have this permission, storage blob data contributor, in my storage account. This is what I do here. So I can use so-called RBAC roles, resource-based access control rules, to specify who is able to access the storage. And I can treat my web app just like a user. It's not a user, it's a service principal, but from a technical perspective for RBAC, it's very similar to a user. And we can check that if I click here on Azure Role Assignment. We will see that in this case, our Azure function has access to storage and key vault. No key, no username, no client certificate, but still something where I can put my access permissions. This is a very important thought here. And if you do want to copy some things from here, feel free to copy something from this Bicep. A very important one is this trick here. for those of you who have done a lot of Azure work, you know that if you change something in Azure Active Directory, then your changes typically don't appear immediately. So Azure Active Directory changes take a while until they are active, typically between 30 seconds or maybe a bunch of minutes. If you would leave this red line here, the line that I marked here in red, if you would leave that out, if you wouldn't have it in your Bicep, then you would have a timing problem. Because then your assignment would try to assign permissions to a managed identity, but the managed identity hasn't been fully created yet in Azure Active Directory. So don't forget to add the principal type service principal here whenever you do permission assignments inside of your Bicep. Otherwise, you will run your script once, you will get a timeout, and you have to run it twice after a few minutes, and then everything will be fine. And that's somewhat not beautiful, right? So at this line, this is important, and that will get rid of these timing issues. Now this is the storage. That is okay, and I think we should give that a try, right? So let's put Key Vault and SQL and so on to the side. We will do that afterwards. Now first, let's try whether code that we deploy in our environment really can access the storage. Let's see. For that, we go back to our infrastructure as code script. So far, we have created the resource group using Bicep. We have created the whole deployment with a lot of stuff. Currently, most importantly, the web app, the Azure function, and the storage. And we will need to do something in the database. We will do that later on. We will need to do something in Azure Active Directory. We will do it later on. For now, I would like to take a look at the code. And for that, I need to package my web app that I have prepared in a Docker container. So let's deal with Docker first. Okay, so let's go here. And let's first go into our web app folder. Here is the web app folder, and build the Docker image. So I will run this Docker build statement. It should be very fast because I've built it just a few minutes before this talk so that we can benefit from caching. This was just as fast as you have seen it now because everything was in cache. So now I can push my Docker image that I created locally onto my Azure Container Registry. I'm going to use an Azure Container Registry because this Azure Container Registry was also deployed in my Bicep file. Here you see the Azure Container Registry. And if you would like to take a look at this Azure Container Registry, you can take a look in Bicep. I will not go into the details here because we focus on managed identity. So let's authenticate at this Azure Container Registry. I, as the user, Rainer Stropek, I am admin, so I can easily authenticate at this Azure Container Registry. And now I can push my image of the web app to the Azure Container Registry. Let's do that. It will only take a few seconds. You see, the bars are wandering from left to right. And in a few seconds, if I keep talking, then everything should be fine. I thought it takes a few moments to upload a few hundred megs to the cloud, but I thought it would be funny and interesting to see everything from scratch. So let's do that. Okay, nice. This was okay. So I can easily update my web app now and tell this web app to now use my new container. So far it was just a dummy container using Nginx, this web server thingy that does nothing special. But now I'm replacing my web app's code with my container image from this container registry. Let's run it, and while it's running, I'm going to show you a very important... Oops, wrong folder. I need to go into the right folder. Now I'm in the right folder and run it again. And now it should be fine. Now there is one very interesting aspect here, because let's think of what's going on. The code is stored in a Docker image, stored in the container registry. But now we tell our web app to grab the container image from the container registry. But how does it do it? We need somehow to give the web app the permission, some kind of authentication, to grab something from the container registry, because the container registry shouldn't be public. It isn't public. And guess what? again, it's just managed identity. Let me show you that. Let's take a look at the infrastructure script again, the Bicep. Let's run that in the background. And let me scroll down a little bit where we have our container registry. Here you see the container registry. And again, I am assigning a permission, in this case, the pull permission. And guess what I'm going to use? The web app's managed identity. I don't create an access key or personal access token for the Azure Container Registry. No, I take the service principal representing my web app as the basis for defining a resource-based access control so that the web app can pull the necessary container image directly from my container registry without needing anything else. No secret. That's the idea here. Okay? So if everything works correctly, it looks good, then our web app should now contain our container. Let's see, deployment center, and let's see, here we are. Beautiful. You see? Here you see it. The download from the Azure Container Registry was done completely passwordless by using the system-assigned managed identity, the service principal of the web app, and this service principal then authenticated at the container registry and pulled down the image. So let's see whether that worked. I have prepared, this is by the way the code of the web app. I will show you some things, but we will not go into the details because today we will focus on managed identity. So the first, I implemented a very simple ping endpoint. And where is my web app? Here is my web app, and let's scroll down. You see, ping just answers with pong. Let's try. This is the first experiment. Just calling the ping, crossing fingers. Will we get an answer? I'm waiting, you see, down here. Pong! Great! This was a practical example for managed identity. We already did managed identity because we already used managed identity to pull down the container image onto our container runtime environment, in this case, app services. First beautiful thing here. Next thing, I would like to access storage. What have I done for that? Here in the program, let me show you the program again. Here in the program, I have done, here in Azure Storage, I've created two important endpoints. The first one says copy file. This copy file thing takes a URI, for instance, an image, somewhere in the internet. I took an image from a website that I've created, and I can give it a name. And this image from the internet should be grabbed and stored into Azure Storage. And afterwards, I can use the URL to this Azure Storage to take a look at the image. Now the important thing is, how does this code authenticate against Azure Storage? And the whole magic is hidden here. This is managed identity when accessing storage. We simply say default Azure credential. Let me tell you what default Azure credential does in the background. It tries its very best to get hold of a token for, in this case, the storage account. So what it does, the first thing that it checks is, am I running in Azure? If I'm running in Azure, I'm asking my Azure environment, hey Azure, I am running in an app service. I need a token for the storage. Do you have one for me? If managed identity is configured, and if we have permissions to access this storage, then Azure will hand over a token and say, hey, you are running in Azure, so this is proof enough that I can give you this token. Here it is, use it. If it's not running in Azure, it's trying to use the credentials of the developer. So in my case, I logged in using the Azure CLI with my personal credentials, so when I run the same code locally, I can still do debugging and things like that. But it's not using the Azure managed identity, but it's using, for debugging purposes, my developer credentials, my user principal. Otherwise, I wouldn't be able to debug this stuff. So it's important to have these default Azure credentials here. So again, see, no key, no connection string, nothing like that, just default Azure credential. To be honest, there is a lot more going on in this API in the background, so you can tightly define what this default Azure credential stuff is doing, and there are also other classes where you can specifically use a very specific way of grabbing the token, but in 99% of the cases you simply say default Azure credential. I always call this Harry Potter programming. It's a little bit of fairy dust and magically it just works, and it really just works. Let's see. Let's see if I'm not over-promising here. So let's call this copy file method, and in this case I'm grabbing a picture from our programming club for kids here, and I'm going to upload it to Azure Storage. So let's run this post method here. Let's see, crossing fingers, crossing fingers. Nice, nice. It says created. So this shows me that it now read this image from the internet and copied it onto our blob store, you see? And it didn't have any keys. No keys at all. Everything was done with Managed Identity. So let's try whether we can grab the image from here. Here you see I have a GET request which takes this location header here. And let's see. Nice. This is a picture of our programming club, and there they are soldering and electronic tinkering with kids. This is a picture that I took a few months ago. So you see, this was very nice for Azure Storage. I'm happy with that. If you have any questions, feel free to interrupt me. Let's take a look at the next step. Now you've seen that it works really nice with Azure Storage, but what about other infrastructure components? I have added as a demo for the next thing a Key Vault access. Sometimes you need Key Vault. What do you store in Key Vault? In Key Vault you can store encryption or decryption keys, you can store certificates there, you can even store secrets for APIs that don't support Managed Identity. Imagine that you would like to access a third-party service, something like Airtable for instance, or Mailgun or SendGrid for sending emails, something like this, and they don't support Managed Identity, so you need to store the API key somewhere. Now what do? You create a Key Vault, you store your keys inside the Key Vault, and you protect the Key Vault with Managed Identity. That's the idea. So here we have the Key Vault, and this Key Vault again is connected to everything, to my whole Azure environment, and I'm using the same Managed Identity magic again. Here you see the web app principle, that's the Managed Identity, the service principle of the web app, now gets Key Vault secret officer permissions for our Key Vault. I don't think I have to repeat it again. No key, no other certificate or connection string secret or whatever. I'm just taking the Managed Identity to do role-based access permissions. And again, the principal type is important because otherwise you have timing issues. So if everything works correctly, it should just magically work. But let me show you that here in the Azure portal. Let's go into the Key Vault and let's take a look at the access control here. I promised you that this magically works. Let's see. View access to this resource, and here I will limit it to scope this resource, and this is exactly what I wanted to show you. For development purposes, my user principle is added here. But this is the Managed Identity stuff here. Here you see my web app, and here you see the Azure function, and both should have access to secrets. Of course, you can limit that. You can see one can only read secrets, the other can write secrets. That is something that you have to design as an Azure architect. But the important thing is that this is everything based on the Managed Identity of the web app and the function. Good, let's try it. In my sample code, I have added here a section, Azure Key Vault, where I can keep a secret, where I can specify a name and the value of a secret. And then I have a second call here that is called get secret. And this get secret will now get the secret with the name and return it in plain text. Of course, that doesn't make sense, because if it's secret, I shouldn't offer a get method to read the secret. But for demo purposes, please bear with me. And do you know how I get the access key for the Azure Key Vault? Haha, see it? Default Azure credential. I simply say, give me a secret client, which is part of the Key Vault API, and instead of specifying some kind of API, I'm again just using default Azure credential. So the fact that my code runs in Azure is enough that I get authenticated. And then based on the authentication, role-based access control is applied, and Azure will find out whether this managed identity should have the permissions to access secrets. And in my case, this should be the case. So let's take a look here at the requests, and you see here I have a demo secret. It says my secret, and the value is some kind of password stuff. Let's run it. Okay, I got no error, and now we will say get secret, and woohoo, it worked. I got my secret back. So you see, I was able to access Key Vault. Key Vault is important when you talk about managed identity, because sometimes, as I said, there are services which don't support managed identity. Then put these secrets into Key Vault and protect Key Vault with managed identity, and you are good and you are fine. Next one, SQL. Now I wanted you to show how we can access a SQL database. SQL database is a teeny bit more complicated, because with SQL we don't have role-based access control within Azure. Instead, we have the access control going on inside the SQL server. So the important thing here, and I have prepared that here, let me quickly run that one. So I don't need to come up with this code myself. The important thing is that magically my managed identities are also available as users inside of SQL. I can create the user, give it the name of the function or the web app, and then specify from external provider. Let's run that. So let's fire up the Azure Data Studio. Here it is. Here it is. Later, I don't need an update now. And I have already, if everything works correctly, set up the server here. This is our new server that I just deployed for you. Let's create a new window. Let's put that here and select our new database. And you see, I'm creating SQL users based on the managed identities that I created in Azure. So let's run this. And it worked. Now we have the users inside of my SQL database. And with that, it should be enough to access the database. Now you might ask yourself, how does the connection string look like? I will show you that. Let's take a look at the program here, and the next section here is Azure SQL, and this is how the connection string looks like. You simply say server, which is some server in Azure, database, which is some database in Azure, no username, no password, nothing like that. Instead, I am going to use the new default Azure credentials, and I'm grabbing a generic token, a general token for accessing SQL databases. I'm saying give me a token for database windows.net. And then I can use this token that I just got, and I can assign it to the regular SQL connection that you probably know and love. And once it has this token, I can open the connection. No username, no password, nothing like that. Simply the access token acquired through managed identity. And again, default Azure credential is smart enough that if I debug this code locally, you have to trust me, I don't have the time to show you that, but it really works. You can try it on your own computer if you want. If you debug it locally, it will use my user principal to grab the token for Azure SQL database, and it will check whether my user is allowed to access the database. This is what's going on. And of course, in a technical talk, 42 has to be part of the talk, so the SQL statement that I'm firing up here as a demo here is just select 42 as answer. So if the next demo returns 42, I am happy and we have the answer to everything, at least the answer to managed identity. Let's see. Here I have this from DB endpoint. Let's run it. This is the sample that I'm most afraid of, and it worked. Ah, nice. You see, answer 42. So now we were able to access storage. We were able to access Key Vault. We were able to access a relational database. And the same is true for other storage systems like Cosmos DB and so on. You could follow the same steps that I showed you here. Okay, very nice. So one question that might come up for some of you is, what's going on behind the scenes? How does my code running in Azure talk to Azure and ask Azure for the token? And I can show you what's going on behind the scenes by taking a look at a raw token. This is what I wanted to show you. By raw token, by this sample code here. What is going on here? In this case, I'm again grabbing a token for my storage account. This is the storage account. But this time, I'm not using this magic default Azure credential stuff, but I'm doing it by hand. And the important thing to note here is that, as you can see here, the IP address 169.254.169.254. This is the same IP address in every Azure system that's participating in Managed Identity. This is an IP address that is from Azure mounted in each network, and every system, a virtual machine, an app service, any other runtime environment where your code runs can go to 169.254 and ask for a token. And this IP address will then understand, where does the request come from? Oh, it comes from a web app. Does this web app has a managed identity? Yes, it has. Nice. Is this web app allowed to access the storage account, for instance, that it wants to access? Yes, it is. And if all the answers are yes, then this URL, this IP address, will return an access token. And then we can use this access token whenever we want to access, for instance, a storage account. Something like this. So this is going on behind the scenes. We have another 15 minutes and then we are done. Then we have completed our 1 hour. So the last 15 minutes, what should we do in the last 15 minutes? I thought it would be a good idea to do something that is a little bit more advanced. Think of the following scenario. You have here in the front end some kind of web app. Now this web app is some kind of microservice, and this web app would like to access some business, let's say backend service. This is an Azure function in our case. So the web app here would like to access the backend service, and the authentication from the web app to the backend service should run with Azure Active Directory. The question is, where does the web app get the token for accessing the backend service? And the answer is, you guessed it, right? Managed Identity. Correct. What we can do, we can use Managed Identity not just for Azure built-in services, but we can use Managed Identity for authentication between our own microservices, between our own services running in Azure. And this is what I'm going to show you. So the first thing that we need to do is we need to create an app registration. And I have scripted that here. Let me run that. This app registration goes to Azure Active Directory and registers an app. Let me show you. If you are not that familiar with Azure Active Directory, bear with me. I will walk you through. Nobody has to be afraid. So let's go here to app registrations. And I think it would be a good idea to just sort this guy here, and let's take a look. This is the one that I just created with my script. Now you see, the name is just a name. It doesn't matter. And the only thing that my script changed was here, this expose an API, and here, this application ID URI. Now, Azure newbies typically would now get maybe a little bit unrelaxed because it's still empty and I just ran my script. Shouldn't it be here? Relax. Whenever you change something in Azure Active Directory, fetch a coffee, come back in a few seconds or minutes, and suddenly things will just work. It takes a while. Whatever you do with Azure Active Directory, be patient. It takes a while. So let's just refresh the browser window. I hope I talked long enough, and here you are. You see, magic hands. It just happened behind the scenes. So what I did, I created an application ID, and this application ID is now the so-called audience. This now identifies worldwide uniquely my API. So this one is part of my own Azure Active Directory, my Rainer Time Cockpit on Microsoft Com. Sorry, I have to get rid of my cat. Say hi. Okay, Continue. This is in my own Azure Active Directory, so I can make sure that this thing is really unique. And now my web app can ask Azure Active Directory for a token for this API. And then inside of my Azure function, which will act in my demo as the endpoint, as the backend API if you want, I use exactly that, see, audience for verifying the Azure Active Directory job token. So the web app, the front-end web app, will ask Managed Identity, give me an API, not for storage, not for SQL, not for Key Vault, but for this backend API running a time cockpit on Microsoft.com. Then Azure Active Directory will give it a token, and then it can present this token whenever it accesses the backend microservice. In this case, our Azure function. And this is pretty powerful. We don't need to use some function API keys where we don't know to store them, and we don't need to manually create a service principal or a certificate-based authentication. No, it's just managed identity. Well, let's see if it works. Let's see if it works. Okay, for that we have to do a little bit more work because I need to deploy my function. We created everything from scratch, so we have now my web app, we have the app registration, we have the function, but we have nothing deployed inside of the function. So let's deploy this function. And just to cover as many different options as possible, I did decide not to go for a container for Azure Functions, but here I'm using the so-called run from package functionality. So I'm building my Azure function, and it's packaged up in a zip file, and then this zip file is uploaded onto Azure. Onto my function environment. And you see, this is now the archive, that's a zip file, and the Azure Function runtime will pick up this zip file and run my function from there. It's really nice. It's a very good way of running Azure Functions with .NET. It takes a few more moments until the function is live. It just takes a few more moments. Hopefully, everything's good. Yes, very good. Here you see, my function is there. And let me check if that worked. So let's go here to my Azure function inside of my resource group. And let's check whether we have some functions here. No results. Let's run it again, just to make sure. So do we have any questions in the meantime? I will check the chat. I see there is a question in the chat. To give there is a question here. To give access to SQL database, is it always done manually, or is there a way to do it by script? Especially PowerShell in your case? Yes, absolutely. In PowerShell, what you can do is you can connect to the database using, I think, .NET objects. I'm not a PowerShell guy. And then simply create the uses using PowerShell. So what you can do is you can create a PowerShell script. You can make it part of your Bicep. And inside of your Bicep template, you can run the PowerShell script within your deployment. So you can do it manually, for instance, in your app, or you can do it using PowerShell. Also using SQL CMD if you are not in PowerShell. So I hope this answers your question. So let's see if my second try was better. And I think I already saw some functions. Nice! Now it worked. Good. Very good. So let's go to requests and let's try it. First one is I call the ping method in the backend. The ping method in the backend is really trivial. You see, it just answers with pong. Let's see. Here we are, requests, and call it. It answered. You have to understand that this thing did not directly hit the Azure function, but it called the web API, which is here. Let's scroll down, down here. This is the ping backend. It hit the web API, and then the web API did another HTTP request to the backend, and the first demo here did not inject any token. No access token here in this request. But then I have a second one here, the secure ping backend. And if I take a look at the health ping implementation here, the secure ping method in the function is validating the authorization header. You can take a look at the code, how it's done. It's simply validating the jar token using typical Azure Active Directory code to validate whether this token is okay. And this code is then checking whether the token is really for this API. This is the API that belongs to me, that is my backend APIs, and this is the API that I would like to protect. So this is the second call here. And now, crossing fingers, run it. Let's see. Oh yeah, it worked. For demo purposes, I'm simply returning all the claims which are in the Managed Identity Azure Active Directory token. So these are the claims in the jar token. You see, for instance, the audience. This is the API. You see the issuer was Azure Active Directory. You see not before. You see expiring. You see the app ID of the caller who just called me. So the backend can make a decision who just sent this request. Is this front-end API? Is this front-end API? And decide what to do. So this was now a 2-hop, and it seems like nothing. But that is exactly the point with Managed Identity. It's so simple. I didn't do anything with service principals or certificate authentication. I simply said, I would like to have a token, dear Azure Active Directory, and I sent it to my backend API, and there I simply checked it. I can visualize this token because I have implemented this backend token endpoint, which will give us, for demo purposes, never do that in practice, please. It will give us the jar token, and we can go into my browser here and go to jar.io and debug this token. This is just the token that my web API got. And if I zoom in here a little bit, here you see it, then you see this is the correct audience, this is the correct issuer, this has the correct timing information. Here you see the app ID. So this is the token that the web app got and sent to the backend. And in the backend, I can validate this token that everything is okay. So this demo showed you how to use Managed Identity, not with storage, not with Key Vault, not with any Azure built-in service, but with a custom service, with a custom backend API that you would like to create. And this is exactly what I wanted to show you. Let me check. Yeah, I showed you all the requests. Let me check. Yes, we executed everything, and all the demos really worked. I can't really believe that everything worked, and we deployed everything from scratch, so nothing was baked in. Before we go into the discussion mode and I answer questions as long as you want, let me quickly point you to the code. The code of the entire sample can be found here. I will zoom in. It's on video. I'm recording this talk, so you can look it up in the video, and I will also copy it now into the chat of our nice little meetup here. So if you are personally in the meetup, feel free to grab the link from there. And if you are not in the meetup, you couldn't make it, and you would like to, you watch it on YouTube, for instance, then you can now get it from here. I will also put it in the comment section under the YouTube video, so you can just click on it and take a look at the code. Here in the DevOps area, you see all the Bicep stuff and this thing. Here you see the web API. Here you see the backend function, and that's essentially it. That is how you can run this sample and play with it. This is what I promised you. A bunch of Managed Identity. I hope you had fun. I hope you learned something new. That's all I have for you today. I would like to say thank you for having me today. And I think we should now move it to Q&A, to question answer. Thank you very much.